All right, here's the 4.5 homework, a longer homework assignment in terms of the problems that you need to do, but I think a lot of them will go fairly quickly for you. Definitely a topic you want lots of repetition on, hence the length. Hopefully it feels about the right length and it doesn't feel like I'm just wasting your time. This first question says, which of the following is equivalent to the log base b of 5? So my advice is for each of these 5, see how you can rewrite them. Try to use some exponent rules. In some cases, the exponent rule might be fairly straightforward, and in some cases, it might be a little bit more challenging to know which exponent rule to use. But I think if you look at each of these and try to apply exponent rules, you'll be able to figure out whether you can rewrite it in this form. Question 2, pretty straightforward application of the first exponent rule that deals with the sum of two different logs. Note that no log base is given here, so implied is that it's log base 10. I don't think I really have anything exciting to say on this one. This one, you got a few options in terms of how you could attack it. You could use your third exponent rule on each of them to bring the exponents down in front of the logs, but then in that form, you'd have a 5 as a coefficient on both of those, so you couldn't immediately use your first log rule on this sum. But if you factored out those 5s, then what is left in the parentheses, you could use your first log rule on. Another option is just to use your first log rule right off the bat, to not use your third log rule at all, and just see what you get when you get 2 to the 5th power times 5 to the 5th power. Your second exponent rule might help you evaluate that thing. Fourth one, this is another application of the first log rule that deals with the log of a sum. I kind of like this one though because the log base 2 of 50 is not something you know, nor is the log base 2 of 1.28. But I think when you combine these using your first log rule, it'll turn into a log that you can evaluate and get the right answer. 5, kind of more the same, except now we have 3 terms instead of just 2 terms. On this one, I think you'll end up using all 3 of your log rules. Your third log rule maybe on some coefficients, your first log rule on some sums, and your second one on some differences. So be really careful the order that you apply those, and I think what you'll end up with is something that ends up being a nice whole number, or at worst a fraction, depending on the numbers you get. Question 6, we're still using the first log rule, except now we have some exponents floating around, not just numbers, but that's okay. What you're supposed to do here is simplify this thing, and simplify is a bit ambiguous, but what they want you to do is make it a single logarithm. So right now you have 2 logs, put those together so it's just 1 log, and then make sure that the coefficient on that log is just 1. I don't think there'll be any issues with that in these specific numbers, but if you had a coefficient, you'd have to move it up using the third log rule. 7's a lot like 6 in that you have variables floating around. However, now instead of adding, you're subtracting. So instead of your first log rule, maybe you could use your second log rule. 8 might not look too bad, but I think 8 is a little bit more challenging than 6 and 7 because you cannot immediately apply your second log rule because you have these coefficients out in front. But hopefully we did an example that's pretty similar, which tells you how to deal with those coefficients so that you can apply your second log rule. Question 9, you can kind of see these getting more and more complicated as we go. We have these exponents here, but we're, again, compressing these all into a single log. In question 10, we turn into a different type of question. Everything that we've done so far has been contracting logs. I think this time we're going to expand them. And specifically what expand means is to write this as a sum or difference of logs and make sure that you don't have any exponents in those logs. And while it doesn't explicitly say so here, I think inside the parentheses, you shouldn't have any products or quotients either. So if you see something times something, maybe you can think to use your first log rule, and something divided by something, you could use your second log rule. And that's not just for question 10, it's the same idea for question 11, where you're supposed to expand this as much as you can. Ditto on question 12, on question 13, and on question 14, and on question 15. On all of these expansion ones, so 10 through 15, be really careful with your parentheses. Be really careful the order you apply your different rules. It's tempting to look at these and just try to jump to what the final answer might be. But I really recommend writing them out carefully, line by line, and making sure you can really justify going from one line to the next, which rule you're using and exactly how you should use it. These are an instance in math where you can be really close to the right answer and not quite right. And I think just close won't be enough with logs. They're kind of a precise kind of thing. And if you're not getting these exactly right, it'll make the next section really challenging. And then we move on to the last type of problem in here. They show up in 16, 17, and this extra credit one, 18. And the idea on all 3 of these is what you're going to end up doing is using those log identities that I talked about. I think that was the last video that I did, the one with the change of base formula. I also introduced 2 log identities. And essentially what they tell you is when the base on the exponent and the base on the log are the same, it allows them to simplify really nicely. So maybe you can use those identifiers to simplify A, B, C here. I think what you'll find is 16 goes pretty smoothly, but 17 is a little bit more challenging because the base on the exponent is not the exact same as the base on the log, but maybe you can rewrite the base on the exponent in terms of the base on the log. So maybe instead of 49 here, you could write 7 raised up to some power. Maybe instead of 6 here, you could write 36 raised up to some power. And then a little bit of algebraic manipulation will allow you to use those identities that I keep referring to. 18 is a lot like 16 and 17 kind of put together. There's more of them. I just kind of figured if you've done 16 and 17, that's probably sufficient, but why not throw one extra credit one on here just in case people want to do it. In some cases, the base on the exponent matches the base on the log, and in some cases, those bases don't match, or you have a coefficient that you have to deal with before you apply those identities. That's this homework assignment. It might take you a little while, but again, that was intentional. I think this is a good spot to spend a little bit of extra time in the class. I'm never trying to waste your time. I think this is a good spot to spend a little bit of extra time, and I'll try to make that up to you in future homework assignments that maybe we can make a little bit shorter.